accepted.
All right. Whew. Zendabere. That work out? That sound reasonably close? I'm not sure. Yeah? Okay. I'm a little nervous. It's been a while. I haven't spoke out in a crowd in a bit. I'm also wondering if I am organized as I would like to be, but we'll see. There's a lot of content to cover. I try to, in a foreign land, slow down, and I'm not going to do that here, so that's my first opportunity to fail. But we'll see where we're at. Also, some of this is somewhat intro. It's kind of getting started in the architectural space, setting some playing field here. I'm here all week, the rest of the week, till Saturday, so catch me outside. We can get into deeper conversations. Happy to do so. There's only so much you can cover in 50 minutes, and I'm going to see what we can do. Who am I? I'm an architect. I've been doing some architectural work since '96. I used to be an instructor for Rational. I used to teach Rational Rose as well as UML. I was young. I needed the money. I apologize. So there's some jokes in there. I'm also a CNCF committer and a Kubernetes contributor. I've been a distributed application engineer for some time, and I vary in Java, Go. Ted's talk was actually kind of awesome. It was like memory lane kind of stuff. But let's talk about architects, what we do, what we're about, and then we'll dive into some architectural principles. The first is, what is an architect? Where do they come from? What do they do? This is an interesting situation, right? I was traveling a few months ago, ran into a lady I didn't know. We started chatting on the elevator. She was an architect. I was like, oh yeah, trying to understand each other just a tad, and it turned out she was a building architect. Very different. What was really interesting about that experience is she was, for the most part, a few years out of university, which made me think a little bit. In our industry, do you go to uni and become an architect? It's an interesting concept. We'll talk a little bit deeper about that in a second. What do they do? Well, Martin Fowler likes to define a few things here that I think are worth visiting. They have a shared understanding of expert developers. Having system design, we probably need to talk a little bit more about that. They make the decisions that you wish you would get right early in a project. He completes this thinking. Architecture is about the important stuff, whatever that is. Well, there's a lot missing there, right? Let's talk about it just a little bit deeper than that. What is that? What is architecture? What is it, the thing that we do? Well, I had to go, of course, to our AI overlords and ask ChatGPT, what is this thing? It's like overall structure design. It's focused on scalability, maintainability, and efficiency. Interesting thoughts. What's important, in part, and we will get there, is context. I used to write some systems for GoGo, which is a software company in the US focused on in-flight entertainment. My architectural skills were at play here. But the one thing that I knew for sure was that I could only get a couple hundred people in a seat in a plane, which meant my scale was limited. But I was also limited in other ways, because we were dealing with an autonomous system that was oceanic, which meant I was dealing with satellites. So those are the kind of constraints that are important. You need to understand the environment you're in that plays out in how we do architecture, which also means a couple of things. One, how I view systems and handle architecture may be different than how you view architecture and its importance as it pertains to the thing you're architecting. We can get into these semantic arguments and discussions, and it just may be that you've never had the experience of dealing with the level of scale that I have been working with, and vice versa. So we'll get into these arguments. In fact, there's two times I often see architects arguing with each other. One is they're arguing over different scales, or they're arguing over different time windows. And that might be an interesting concept we'll dive into a little bit later. When I define an architect, or when I'm hiring an architect, I consider them to be T-shaped. What does that mean? That means they have some level of depth, and they have a lot of breadth of experience. Hence this challenge that we have. We don't go to the university and become an architect. You have to have this exposure. Another way of putting this that might be useful is I can look at a resume, and if this is a Java developer, let's say, and they've been in the industry for 9 years, after talking with them, looking at their resume, I could go, you know what, you look like an interesting person, but you don't have 9 years of experience. You have 1 year of experience repeated 9 times. Does this make sense? There is an evolution that you get to. If the depth of your T is Java, I'm going to ask you some interesting questions. One of them may be, what is your biggest pet peeve with Java? And if your biggest pet peeve with Java is like, well, it's a little verbose, I'm challenged in these ways, well, that's one level of awareness, and it's usually somewhat junior. I mean, we're going to talk about verbosity if it's necessary, but that's not the biggest concerns that you have from an engineering discipline standpoint. Your biggest, when I hear a different story when asked that question, well, how we handle the difference between primitive types and object types when you get into reflection, it's a whole different level of experience. All right? It's just a completely different awareness of where your pain points are. I have just found through history, through my experience, that asking what your pet peeves are is a great litmus test for how you are disciplined in your given space. So when we get into T-shape, all I care about is what's the depth of your T. It's probably my first question on an interview is, where do you find yourself to be most technically expert? And then I'm going to dive in deep. I don't necessarily care where it's at, so we'll dive in deeper in that space. As we mentioned, since we don't have architects coming out of the university, where do they come from? Well, it is typical that you become a developer and then you have a choice. You want more money, you want more authority, whatever the reasons are, you tend to have a fork in the road. You either become a project manager or you become an architect. Now, we get into this next problem space that we want to address here, and that is sometimes in some organizations, the role of architect is a rung. It's not, in some cases, it's just you're a more senior engineer. You're not actually doing true architecture. So we get another opportunity for lack of clarity, if you will, around this role. So, have you ever met like a 10x programmer? Maybe it's you, maybe it's someone you know, right? And they're amazing, and of course management's like, can we get him or her to manage other people, and we can create 10 of them, right? That's what they're looking for. Can I get 10 of them? Have you ever seen that person promoted to be an architect and then they fail miserably? What are the skills necessary to be an amazing programmer, to be 10x? Hyper-focus, well-tuned to your language of choice, good application of those skills in that space. You can be alone in the closet, drinking Mountain Dew and eating pizza, and that's what is great, right? What makes a great architect? It's a completely different skill set. Communication, soft skills become very, very important. All of a sudden, being in the closet, being alone with your cone of silence is not the useful element anymore. In fact, it's the antithesis of what you want. You need to be able to look at things and see things from an abstraction layer, not from a low-level programmatic layer. So these skills are insanely different. And that's one of the first things as you career path into the architectural space that people run into challenges. I forget the gentleman's name, but the second person speaker up here today was talking about we're all introverts. I don't know if we're all introverts, but many of us are. And that can be a real extra challenge when moving into the architectural space. And that doesn't mean you have to be an extrovert to be an architect at all. I don't mean that. But you have to be able to clearly define, document, and share understanding across your teams. So what is it that an architect does? Well, it varies. We have a lot of different architects. We'll talk through several of them. Right now I run a team of enterprise architects. Boy, that's a tough one. Enterprise architects, what is the challenge there? Well, it's really great if you're an application architect. I can literally define prescriptively, this will use MVC, Spring MVC with Java. At an enterprise level, depending on the size of the enterprise, I can't. It's really challenging to define guardrails without being too prescriptive. The balance is really challenging. So we'll see different layers of architects. We won't have time in this session to go into deep detail on each one of them. Just know that the way you look at the system and work with the team is strongly different depending on what role you're taking. But when we think about architecture in general, we might be thinking about system structure, logical views, physical views. You might be diving into the tech stack as an application architect, defining certain aspects of it. You might be defining the infrastructure of it. This is one of my current latest concerns, where I start diving into chassis, into the units that go into a chassis, into connectivity and having true fault tolerance across those network connections. It's really, really challenging stuff. What do we really do? Well, I could summarize it into we fight entropy. Entropy being the natural tendency for things to fall into chaos. We bring order to it. That's the core of what we do, which means organizing ideas, organizing people, and bringing sanity, if you will, to the environment. When we think about different types of architects, we have business architects, application architects, information architects, greatly missed in the spaces that I tend to see a lot of. Solution architects, domain architects. What is a domain architect? Well, they know one specific domain extremely well, but they're kind of siloed in that space, and sometimes it's insanely useful. So we're going to do, this is a little bit of a challenge. I usually have this presentation in a much smaller audience. We're going to see if this works here, but we're going to run some tests real quick. Maybe we'll do a show of hands. A quick architectural check-in. First, which is better, loose or tight coupling? Who thinks loose is better? My favorite consultant down here. I don't know if you all heard that. He says it depends. The perfect consultant word. Here's the problem that we have in the industry. One, when you look at the spectrum of things, we might be erring, commonly failing in a certain area. So the spectrum is leaning this way, we're too tight. And so all the literature that you see, all the presentations you see, they tend to hyper-focus on we need to correct. And the corrections we kind of need commonly today is to be less tight and more loose. And so there's this huge push for loose. If I were to give an interview to architects and I ask this question, which I commonly do, 80% of the time people say loose. And actually, I don't actually care. By the way, your answer would be my favorite answer, so kudos. I don't really care. What I care about most is how do you think? So you're going to answer the question, and I'm always going to come back with, well, tell me a time when that's not true. Like, the skill of being a really good architect. So when I went to high school, long time ago, sorry, but it's just where I am in life, one of my favorite things that I did, I didn't know it at the time, but I took speech and debate. And one of the things that you have to do to be really great at speech and debate is I have to be able to win on both sides of the argument. You will be on the pro side or the con side of the argument, and you will have to win on both sides. What does that require you to do? It requires you to intimately know the other side and have the greatest arguments and discussions on against or for it. That's what we do as architects. I did not realize that was going to be such an amazing career path for me in what I do today. I have to know when. When is tight better? When is loose better? We just so happen to have a lot of failures in the tight space, a lot of frigidity, a lot of failures where we have to come back and revisit things. When does it matter, by the way? We said depends, but depends on what? Well, you probably ought to think about things that you control and things you don't control, and you should definitely be thinking about life cycles, which we don't tend to talk about enough. If I have separate life cycles, I need to decouple them. As I need to decouple things, they need to be loose. When do I want to be tight? Well, there's use cases for which, if you're building trading systems, you're actually doing trading, the amount of latency associated with loosely coupled systems is horrific, and I have to be tight. I also want to be tight within a component. So I want to be loose outside of the component and tight inside the component. There's a lot of discussion that we can have in that space. In the 90s, Microsoft came out with an interesting technology called COM. And what it essentially defined is a way of doing things loose and a way of doing things tight. It had a dual interface, we called it. In one space, we had direct APIs that we could call. In another space, we could call IUnknown and iDispatch. What did everybody use? Well, back in these days, generally speaking, everybody went tight because we were looking for low latency. We were looking for productivity, maintainability, a variety of things that we were looking at. When did we go loose? Well, whenever we had two technologies that needed a bridge. I needed to go from COM to Corba in DCOM space. I had a UI that didn't know the component that we're dealing with, like Visual Basic, or there's a variety of other tools that mapped into that space. Question for you. Your first response, don't think too deeply. How many abstractions do you see on the slide? 2. Okay, I've used this slide for a long time now in many countries, and the default thing, I'd say 80% roughly of the times, people come up with 2. What are they? Okay, we might talk about electronics and animals and things like that. Now I got some deeper questions for you. Can you see 6? Yeah, okay. Each one could be their own abstraction. Can you see 1? And what is it? Okay, someone volunteered object, picture, image, clip. What does it depend on? Depends on context. Context. If there's a thing that we need to more accurately understand in an architectural space, is that of context, because context is the thing that majority of the time matters. The context of being in an airplane and captivating an audience that's 200 people with maybe 2 devices each defines a context of scale. That's wholly different than being on land, being in a building, being among the general population. So let's start diving into some principles. Let's talk scale. I had listed in the abstract a number of principles. We won't have time to get to all of them, so I'm going to hit the highlights. You guys have some control, by the way. This is too large an audience to address each one individually, but you guys can attack me later. Scalability. Interesting thing, the thing I wanted to highlight here, you see it in bold, is that of linear. There's this focus of, we want the system to be able to respond in a linear way to stimulus, essentially, at its core. Would you believe me if I told you that there is no such thing? We'll talk about it in a second. It's difficult to talk about scale without talking about the different dimensions of scale. One is vertical scale, one is horizontal scale. When you get into vertical scale, we're talking about how much memory, how much core time, and a variety of other things, depends on what you're interested in. That's the first thing. You need to understand context. Am I dealing with scaling I/O? That's wholly different than scaling to requests. Very different space. If you go into Apple Siri data center, the challenge that you have in that space is I/O. It's an I/O scaling issue. How do you get to higher I/O? Well, first of all, get off virtual machines. What are you talking about? The future is the cloud, Ken. Well, yeah and no, right? Depends. If you want the highest level of scale of I/O, you're going to be focused on bare metal if possible, because we have good evidence that virtual machines actually destroy the scalability of I/O. So refocusing, generally speaking, most people are scaling response times to a larger audience. You want to figure out how much memory, how much core time is needed for a given one process, one thing, vertically scale the thing. Once we understand that, we would then we would horizontally scale to be able to maintain first fault tolerance and then second scalability across a larger load. I mentioned, would you believe me, that there's no linear scale. All systems that I've ever tested, they have a curve to them. And the first thing, this is the thing I love about our industry, it's a beautiful combination of art and science. Problem is too many people aren't doing the science part. Need to actually measure stuff. Got to load test it. Got to put it under load. I have to know. Then we can get artsy. There's no guessing. I don't understand that. That's not the space I work from. So we have to put a load on the system. I have to understand usually throughput and response times. Typically what I'm after in most situations, once again, it depends, right? So we'll dive a little bit deeper. Why is this not working? There we go. Now, I stole this image. I borrowed. I reused this image. I would have probably put not concurrent users, but concurrent requests. But this is a great graphic. What do we see here? The first is we have throughput. That's the purple line here. We have response time. That's the blue line here. When we reach scaling limits, here's the interesting part. We could say it always comes down to one thing, abstractly. That one thing is you are tapping out a resource. The hard part, identifying what it is. You are either capping on core time, you're capping memory, you are capping the number of ports on a given node, you're tapping out connection pools. Could be virtual, could be physical. Don't know. You gotta measure, gotta actually understand, gotta profile. So, as I mentioned, we will get to a buckle zone, but I have to know where that's at. So I start to scale it out. If you look at this, I guess, golden line here, the golden line is the summation of those two other lines. On that, we can now predict, based on the dashed line, where are we linear? Which means that nothing is ever linear, but there's parts of it that are. That's the part that I'm trying to understand. I take a pod, I take a process, I scale it, I load test it, I find throughput, and then I try to find the linear utility line, and then I define for myself there, that is where I want alerting to occur. That is where I want horizontal scale to move out. This is the science part of the art and science equation. We need to do more of this. Now, we do this with a given process. Now, we have to add load balancers, we have to add more scale, and we will load test once again at a systems level. I still need to see where those lines may be, and if I call it friction cost, but the amount of latency associated with load balancers has some impact over time. Now, it's so low initially that you will basically have started this. If this is the line on a process, this again is the line on a system, and it's so flat initially. It's wonderful. There's almost no cost. In fact, whatever the friction cost is, you pay it, and then you don't have to pay an additional cost until you start to load, until you start to reach your buckle zone again at a systems level. So let's say we did this for the process, and then that is, let's just say 5,000 concurrent requests per second. Then we start to add additional nodes, and every time I add a node, I get another 5,000 minus the friction cost, but I get something close. But then again, at a systems level, I start to reach a buckle zone. Now, I've done my job. I now have a whole system. I'm now supporting thousands and thousands of users concurrently, but I'm reaching a buckle zone. How is it possible for me to scale this system to the next level? I know I'm reaching a line at a systems level. What do I do next? Principles. Crazy, right? So there's a quote. It's in the slides. I'm going to forward reference it by Randy Shope from eBay, and I love it. It's one of my favorite quotes, actually, from an architectural space. And it is basically summation of systems thinking, systems theory. And he says, if you can't split it, you can't scale it. So wherever the bottleneck is of your system, that is your limiting factor for scale, period. What we would typically do in order to scale out this system to a larger audience than what we can handle with the system as it is now is we would start to split domains. You ever logged into, I don't know, Hotmail or Live, whatever it's called now, I don't use it, but and then all of a sudden you log in and you get put on a subdomain that may be different depending on your login time or where you're at and things of this nature. What are you doing? At login, which has one level of system, we make a determination of where we want to farm you out, where we split traffic. And now you are hitting another subdomain of systems versus another subdomain of systems for another group of people. It's about splitting traffic. Is everybody cool with that? So that is the core principle that we start dealing with when we get into scale. Now, I have found that there's not enough people that understand CAP theorem, and when we talk about scale, we have to talk about CAP. So, CAP theorem is CAP, consistency, availability, partition tolerance. Since we are a microservices-based organization mostly, you get the important part about CAP is you get to pick two of the three. And if we've already determined that we are partition tolerant, we have a distributed system, then you get to pick one of the two. The remaining two are consistency or availability. Now, most people will pick availability. Most people will pick consistency. We can't have data that is not consistent. And that works fine until it doesn't. Now, the hard part here is as an architect, you're going to find yourself fighting it. You're going to fight it. I've been there. I know it. You're going to fight it. What does fighting it look like? We're starting to reach scale limits. We have to, and then you'll start tweaking it. Well, you need to profile it. Let's profile this. Let's try to eke out everything we possibly can. What are you doing? Well, you've spent so much money and time developing this system, you're going to keep tweaking it until you reach your maximum number of tweaks. And what you're fighting is, in order to fix it, you have to rewrite it. The cost of rewriting it is heavy. And the cost of rewriting it is not just heavy because of the rewrite, it's heavy because you have to go in a different direction. You have to start thinking in a consistent, like in a world where you're not going to be consistent, where you get to be eventually consistent. Now all of a sudden you run into problems because the user experience may change completely, and I have to accommodate for that. I also might build systems that are gracefully, I can't, sorry, my brain is still at like 2 a.m., I think. So the challenge is you need to be able to gracefully degrade services. That was the words I was looking for. So if a system's down, I want to be able to not know it necessarily, or to change the UI to reflect it. So back on CAP theorem. We get to choose consistency or availability. Why? Well, if we are focused on consistency, you're talking about XA compliant, two-phase commit transactions. So I want to keep two data stores consistent with each other. When I do that, I get this. I get a lot of chatter. I get, hey, we're about to commit this. Are you ready? Yes, I'm ready. There's a lot of voting back and forth until we get to a consistent space. It's very, very chatty. It's super expensive. It's also near free. You can buy an XA compliant two-phase commit. You don't have to buy it. It's open source. You get this for free if you want it. It's near free. Even if it's not free, you can buy it. Here's the hard part. You move into a space where you have eventual consistency, there's nothing to buy. It's completely on you. It's completely your teams and your technical talent. There is no solution that you can buy. You just have to learn certain disciplines. Like I have to focus and understand what idempotency means and how to get it. And it's super expensive because there's humans involved, and because there's a lot of technical talent involved, and because we don't have anything that you can just buy. So you're going to fight. Welcome to Fight Club, right? Consistency is what we all desire. The reality is, if you want the highest level of availability, now I'm talking, you may not have this. Make sure you pick the right solution for your context. I have been working with Netflix and with Riot Games and with Apple. Their level of scale is just different. That's not the space I'm working in now. I'm working in the fintech, financial space. The level of scale is just largely different. We have different windows of time. They're super expensive to have more than a couple of nines. It's super expensive to build idempotency. You want to make sure it adds value and apply it where it's appropriate. Even at eBay, who has a need to make sure that they're catering to a large body of people, they still choose, when do I want to make the expense for idempotency and when do I not? We'll see that a little bit later. All right. So availability, we talked about this a little bit. Make sure that you're hitting the mark. What is your core business? What is your non-core business? Those are the things you care about. We're going to talk a little bit later on consistency. There's too many people that try to be consistent across their entire enterprise. This is a mistake, in my opinion. You want to be consistent at the same level of service. And you certainly want to be consistent with your application for business versus non-core business. And that's the hard part. As an architect, one of my jobs, how do I categorize things? Is this business? Is this a core business or not? It's arguable. It's somewhat subjective, but being able to define that drives a lot of other behaviors. So I need to actually go through that process. I literally have to know what's tier 0? Where are my crown jewels? What are the things that if they fail, I have to have a backup plan for? And it's expensive. So I need to be accountable and responsible with it. I would even say that a given project team, not thinking about an enterprise, but just given a project team, The mentality needs to be, there are 2 phases of development. When you ask me to build something, the first phase, is this possible? What does it look like? Have I done it before? That phase would look like a startup company where I would go in and I would do very little design. Why? Because I want to answer the question. In a startup company, I'm like, hey, if I were to build this, would people use it? Does it add value? I need to understand the question. The only thing I care about is, will people use it? Does it add value? Which means you could spend your time building a very mature model and then have it fail. So you could take 6 months to get the answer and then find out it was useless. That doesn't seem responsible. The first thing you want to do is come out with something with light design or no design. See that people are attracted to it and go, holy crap, this is useful. Because it's useful, I now need to rewrite it. This is the thing that most enterprises get wrong. The first step is not to apply my engineering discipline. I just came out of college and I know exactly how to do this and it's going to be awesome. That's the wrong approach. Initially, it's answering the question, is this of value? Once I have that determination, I go into a different mode and I rewrite with the understanding of what's the right scale, how do I make this maintainable? Now it's worth the vested interest to invest into it. This is the standard model they work with, which confuses people often. Now there's a few things on every project I always have. I'm always going to have a linter. I could go through the list of things that I would always have. It helps me be better at what I do, but I'm not going to go with heavy design on something we don't have an answer for yet until I know. When we have confidence that this is useful, then I'm going to engineer it correctly. Talked about Randy Shope earlier. All right, some references for scale if you want to get out there. They're useful. Flexible software. So you get into the system. You start to think, hey, I need this to be flexible. We're going to be loose. You start to have this vision. I got to have this silo connected to that silo. We envision to build a bridge, and it's going to be loosely coupled, but it looks more like this in the real world. Does it connect? Maybe, right? So we have a lot of interconnected systems, a lot of dependencies. We think we're going to have growth. We imagine this. We do have growth, and it looks more like that. And so we start to see diagrams that might look like this. We saw this in the aughts. Right, we call it the enterprise service bus. Here's the problem. This looks pictorially interesting. Leaders without technical aptitude will go, yeah, that's awesome, that's great. The reality is everything that you saw from a complexity standpoint are now baked into routing that's inside of a proprietary system in most cases, which is an illusion. It's an illusion, which is in part why it didn't pan out so well. When we move into a space that's loosely coupled and has a lot of flexibility, idempotency, the number of times I see an architect that has no idea what that word means is high. And all idempotent means is that it's like functional language. If I put in an input, I get the same exact output. And what does an idempotent system look like? Well, if you go to a data store and you're like, hey, this record, delete this record, and it says, okay. And I say, wait a minute, I don't know if that worked or not. Delete this record, and it comes back, that record doesn't exist. Those are 2 different types of responses. That is not idempotent, right? In fact, frankly, REST APIs, one of its definitions is idempotency. I tend to think that most RESTful services are actually just HTTP RPC. We're just connecting RPC, remote procedure calls across HTTP. They're not even true REST. Now, that's me being a little pedantic. That's me being a little critical. But that's the reality of the world. Idempotency is super expensive. Why would you want it? Because I want a stream of events coming in. I want a failure to occur. It's not like I want it to occur. But I have to design everything always fails, period. I'm telling you, they always fail. What I don't want is it to be realized. So, knowing that it will fail, having a stream of events come in, I have a time window where I know something bad happened. I want to be able to rewind the pointer in the stream, replay it, and not have duplicate records. I want the same exact end consistency as would be if I replay the same thing that's already been played a couple of times. I want the same end result. That's hard. It's just hard. I'm telling you, it's hard. But it's worth it. If you want highly available systems, that's what we have to drive to. And it's super expensive because, once again, can't buy it. You can't buy it. It's got to be in here. It's got to be a mental model I share with my team. So we talked a little bit about loose and tight. I think I'm going to avoid this for the sake of time. Performance. So performance versus scale, they are interconnected in some ways. Performance usually is my throughput or responses. What I want to talk about here, though, is when we talk about NFRs or non-functional requirements. Oh, here's the other part of an architect. I actually am surprised I haven't brought this up yet. When you get all your use cases, your stories, you get that from the business user, there's always a space of what we do that they never tell you, right? They don't even know. They're like, Ken, could you make this faster? The response time's a little slow. I don't want to wait for the spinning wheel of death. Can you just make that faster? That's what they tell me, right? It's up to me to determine non-functional requirements. What is the response time? Which, by the way, directly influences the user experience. You know, I could build out a whole system and it only works for one person. That's not super useful, right? So it's easy to fail. Even if you got the requirements 100% right, you nailed the user experience from a business user standpoint. If it can't scale to more than a couple people, it's likely not to succeed. So what we do, how we apply this technique is super important because we directly have an impact on its success. The problem that I see is that when we define non-functional requirements, I need this response back in sub half second. We leave out something very commonly, which is critical. Based on what? This will have sub half second or sub 500 millisecond times at a load of 10,000 concurrent requests. That is now useful. Without load, it's useless. I need to know where my scalability curve is, where I am on that line. I can't hold an SLO, a service level objective, without understanding the load that is applicable to the non-functional requirements defined. So performance has an impact in that it will drive how I scale things out. Maintainability. Now, I'm not talking about maintainability of code. That would be Ted's talk. I'm talking about maintainability of the system. And what do we need to have? Well, we have to hyper-focus on three things, the three pillars of observability. We have to understand metrics and tracing and logs. These things all go together for helping us understand and maintain our systems. One of the problems that we have is people, once again, trying to buy the solution. So they buy Dynatrace. By the way, cool tool. I'm not dogging on that at all. It's a super awesome tool. I think they're actually one of the sponsors out here, so you might want to check them out. But you can't just buy this. One of the things you have to drive for are what are the golden signals. You have to seek out where there is a signal versus noise. These things are insanely noisy. As you get to different levels of maturity, you will start to hone in on the golden signals, and there will be very few of them. When you get to Netflix level, Netflix defines, for the most part, one of their core golden signals is click to play. That's it. They know lots of things based on that one signal. What do they know? Well, if somebody clicks to play and they keep clicking, well, they might have some queuing issues. They might have some streaming issues because someone is pausing and then replaying. And they see that across some demographic. It could be over here in Europe. It could be in the US. And now all of a sudden they start to narrow their scope of where this issue may lie. They may not see, based on heuristics, based on history, they may not see click to play. It might be less than they're used to. Well, now they have connectivity issues. The users can't actually even get to the click, or the response isn't getting back to their servers. That one event has a significant impact. Now, you get Dynatrace or something like it, you install it, you think you're done. Now you've got like hundreds of garbage collection events, and you're like, what do I do with this? Those aren't useful. I mean, they're useful later, maybe, but they aren't useful initially. You need to understand and define what your metrics are. It's a core part of making sure that you have good maintainable systems. And I don't care what tool you're using, actually. Logging, Splunk, Elk, doesn't matter. You got to have it. This is the part of being mature in when you build out a system, It's not a system until it's productionized. When I say something's productionized, it's been instrumented in order to be involved in observability, to enable SRE functions. Right? There's a variety of things that go in there. Be consistent. Well, this was a questionable one, but I'm gonna dive into it. You want to be consistent with the same level of service and not across the enterprise. Not everything's going to have 4 nines, nor would you want to pay that expense, nor would you need it. When you get into eBay, I thought it was very interesting. It's possible, used to be possible, this is years ago for me now, they would define their registration system as non-core business. So it was possible for you to try to register as a new user and to have this experience. Hey, this is Ken, blah, 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 submit. Oops, sorry, bad things happen. Can you start over again? Now, that'd be weird, and it's very rare, and they didn't put money into software, but they still had high availability at the hardware level. All good things. But their core business, auctions. Everything will be timely. Everything will be ordered appropriately. Everything will be idempotent. High cost, high reward in that space. Now they have 2 different models. Hey, are we going to apply the discipline associated with core business or non-core business? Because this is cheaper. I can go in here with a in-memory model, component-based model on the UI front. It's cheaper. It's cheaper. It's not where I want to focus my time. Auctions, it's got to be right. It's got to be right every time. Your pro level, consistency. An understanding and a good discipline on eventual consistency and graceful degradation of services. It's hard and it's expensive. But this is pro level, right? The highest level of maturity, being at that level. Let's talk security. I might have to speed it up a bit. Security. You know what? There's a great book. I have a reference to it in a few minutes, a few slides, but I really liked it a lot. It's a book by David LeBlanc and Howard. You'll see it here in a second. But when we come up with stories or use cases, one of the introductions in this space was, hey, how about come up with an abuse case? So you have a use case. How would someone use that use case in an abusive way? But one of the things that it has you focused on is, how can I understand security from the start? It's a hyper-focus on building in security from the very beginning. There was a I won't go through that story. I won't have time. The one thing to know about security is it's always inverse of user experience. This is one of those other great skills as an architect, is being able to tease apart things. When someone says, hey, I want you to build an SSO solution, I don't want people to have to log in twice. What I hear is, oh, I want you to reduce security and create a better user experience. User experience and security are always inverse of each other. When I have someone asking for a better user experience, I start questioning, is my security in jeopardy with this? I want to trust this token created by a third-party system in this system. It may be okay. I'm not saying it's not. I'm saying user experience. What's the most secure machine you've ever seen? It's turned off and it's buried, right? Like, not super useful, right? There's always a level of risk associated with just turning on a computer, making it connected, providing a process on top of it. So you have to understand your level of risk tolerance. But this book, it's a little bit dated. It's a few years back, but I just found it to be super valuable because it's very pragmatic. It actually gives real disciplined answers. It is from Microsoft, our group working with Microsoft, so some of it is kind of tilted that way. Complexity. One of the questions I commonly ask, I find myself asking a lot lately, is this accident? Is this intentional? Right? Those are the 2 levels of complexity. It's accidental. This is real world, by the way. Does it matter where you put the next line? I don't know if it does. Or this. You'll see this later on today. I'm a pilot. I fly a little Piper Cherokee Arrow. That's the cockpit. Some people would look at it and say it looks complex. I would say it's just not familiar. Everything is essential, right? You have to be maybe of the right technical aptitude to understand whether this is essential or not. I can definitely see a junior person going, wow, this is super complex, Ken, the software architecture you built out. They just haven't got there yet. But there's oftentimes I look at a system and I'm like, hey, is this essential or has this just happened? That's an important distinction. Simplicity, it drives understanding, maintainability, easy to troubleshoot. The RTOs or MTTRs, they're all driven based on building systems that are simple. One of the challenges I have with a couple of orgs I've been with is we have security get involved, and they start applying security with different tooling. And now you've got 10 sets of tooling all sitting on top of each other, and you can't understand, is it secure or not? Because they're all disconnected. So bringing simplicity to that is super valuable. All right, we're ending out here shortly. Choices, consequences. If I want to increase security, I'm going to have a negative impact on user experience. I'm also likely to add to the level of complexity. I was going to do a talk at one point about how software architecture is like D&D, and the feedback was, nobody's going to know what you're talking about. And then I find out, everybody knows what I'm talking about. You guys know Dungeons & Dragons, right? So, you pick up the sword, and it's got +2 to dark magic, but it's also negative to, pick something or another. That's what software architecture is. I can't pick up one thing and not affect others. I want to increase security. I'm going to have a negative impact on latency. It's going to be more latent. It's going to have a negative impact on user experience. And now I have to start to balance these things, start to tease them apart. Single sign-on, big negative to security. It's going to add a little bit to complexity. It's going to add higher risks. Your highest level, distributed version control, super hard stuff, of services, I should say. So a couple things in closing, using eBay as an example. One, lessons learned that they had. Design for failure, love it. Everything always fails. The point is to have enough in place that it's not noticeable to the end users. Cloud systems, in the cloud, doesn't matter, AWS, cloud, Google, pick one, Azure. Things are failing all the time, but yet platforms are still up. You don't even notice it. Google, they'll take thousands of hard drives that they're about to install in production and put them in a closet for a month with high reads and writes, trying to break them in. What does that mean? We just happen to know the highest likelihood of failures to happen in the early life cycle of a new component, so we're going to run it through its cycles right now and just throw out the things that don't work, right? So that level of discipline is expensive, but super valuable. Designing for failure. Everything always fails. And then focusing on evolution or architecture. You're never going to get it exactly right, and you're not even going to know where your points of interest are necessarily until you have it in play. You want to embrace inconsistency. This will be hard and expensive. Do it when it's necessary. But for a system that's available to the world, you're likely needing to do this. You're needing to understand the level of inconsistencies that are tolerable and how to manage it. You also want to reduce the amount of physical dependencies. Super valuable as well for lots of reasons. One of their lessons I loved a lot. It's a mistake to worry too much about scale. Counter to that, it's also a mistake not to worry at all. Right? This is where the balance comes in. This is where having a more senior engineer or senior architect involved will automatically apply certain disciplines because they know. As soon as I see a system and I know we're going to chat, like we're on microservices and it's just chatty, I know we're in trouble. As soon as I know we have a huge amount of I/O going across the wire, we're going to pull everything at once, I know we're in trouble. Right? If I know that the data is that I need to interact with is in a different region, I know we could be in trouble. These are warning signs along the way. I don't have to think about it. I've done it. I've seen it. I've seen lots of failures. I've created many failures. It's the value of getting older, I suppose. And with that, thank you. Appreciate your time.